The Blue Ridge Dam and Reservoir were built by Phelps Dodge Corporation in the early 1960s. The Salt River Project agreed to help Phelps Dodge secure Black River water for their copper mining operation in Morenci in exchange for water from the newly built reservoir. SRP acquired the Blue Ridge Reservoir from the Phelps Dodge Corporation in February 2005 as part of the Gila River Indian Water Rights Settlement approved by the United States Congress via the Arizona Water Settlement Act. The agreement settled water rights issues, allowed for the transfer of the reservoir and pipeline operations from Phelps Dodge to SRP, and provided an allocation of 3,500 acre-feet of water annually from the reservoir to northern Gila County communities. At this time, the name of the dam and reservoir was changed to honor C.C. Cragin. Cragin is remembered for his vision of using SRP's Desert Dams system to generate hydroelectric power. The C.C. Cragin project consists of a number of facilities, including the dam and reservoir, a diversion tunnel and pump shaft, pumping plant, priming reservoir, pipeline, electrical transmission line, and a hydroelectric generating plant. From the reservoir, water travels through a 6-foot diameter, 4,400-foot long tunnel and is pumped up some 400 feet by a pump station, which carries the water into the 33-inch pipeline. In order to accommodate the rolling terrain on its 12-mile journey, some 22 sections of the pipeline were built above ground in order to traverse the arroyos. In the wintertime, when the reservoir freezes, water is shut off and the pipeline is emptied. In the spring, a small pump is turned on at the reservoir, and a 2-million-gallon priming tank on the pipeline is filled in order to begin the process of sending the water down the rim. A vacuum breaker is introduced in the form of a water tower just before the water makes a journey down the side of the rim. This prevents rushing water from forming a vacuum inside the pipe, which could collapse and break it. Gravity creates pressure within the pipeline, ideal for running an electric generator down at a power station where the pipeline joins the East Verde River. This generator creates the power that is needed by the pumping station to pull the water out of the reservoir and send it on its way down the pipeline. It's the closest thing to a perpetual motion machine that you might ever see. Because of the age of the system, many repairs and upgrades were needed at the pump station to modernize the systems there. Also, over the years, the above-ground portions of the pipeline cracked and began to leak. These had to be fixed, and the town of Payson, in conjunction with SRP, set out in 2008 to do this. Rather than try to plug the leaks, it was determined that replacing leaking above-ground sections of the pipe was the best way to go. So new pipes were inserted along with new trestles with special plates that allowed for movement of the pipe. At the same time, another act of Congress, the ARRA, or the American Recovery and Reinvestment Act, enabled Payson to receive ARRA stimulus money to purchase 62,000 feet of pipe that accounts for most of the entire pipeline construction project. At that time, the cost of the ductile iron pipes was a bargain compared to today's prices. In 2009, the second phase of this pipeline rehab was completed, including the 2 crossings that are on the downside slope of the rim. Also in August 2009, the comment period portion of the National Environmental Policy Act process took place with a public awareness meeting at Julia Randall Elementary School. This was the beginning of a 4-week period in which input from the public regarding all aspects of the new pipeline project was received. In 2010 and 2011, the town of Payson conducted important tests and research in preparation for treating the water that would be coming down from the Cragin Reservoir. A pilot treatment plant was set up at the power plant site to test the Cragin raw water and determine what would be needed to purify it for use in Payson's existing water system. The water would also have to be buffered because the new surface water is entering a groundwater system where the groundwater has been in contact with underground minerals and deposits and would have a tendency over time to harm the existing system. Speaking of groundwater, the town of Payson will not immediately use all of the new Cragin surface water available to the town. So in order to retain the rights to the water allocation, it was determined that the town would replenish existing wells with some of the surface water allocation not needed for immediate use by Payson's water customers. How could this be done? The new Cragin water will be injected directly into the town's water wells. During 2011, the town of Payson tested and identified 11 of our 42 wells that could be used for the purpose of storing the Cragin water. A variety of potential delivery methods and routes were available to get Payson's allocation of water from Washington Park to Payson, but all of them passed along or through public lands administered by the U.S. Forest Service. The National Environmental Policy Act sets forth the necessity and procedure for conducting an environmental assessment and the responsibility of the town of Payson to conduct studies as directed by the U.S. Forest Service. The studies were completed in 2011. In 2012, the Forest Service issued a special use permit to the town for construction of remaining Cragin project elements. Also in 2012, additional pipelines to transfer treated water from the yet-to-be-constructed water treatment plant to the existing system were installed in North Payson. A new 18-inch pipeline from Zurich Drive to Easy Street to Evergreen Street, across to Manzanita Drive, and down Park Drive to Mud Springs Road was constructed. Also, an 8-inch pipeline from the Elks Club area west on Airport Road to connect to the airport storage tank was added. Another 12-inch water line is necessary to connect to the Rumsey Park water storage tanks and was constructed across Rumsey Park and McLean Roads on West Rumsey Drive. In order for the town of Payson to receive the new Cragin water, a connection of Payson's new 18-inch pipeline to the existing SRP hydroelectric facility located at the headwaters of the East Verde River was necessary. In fall of 2012, construction began on this portion of the project, including a tail race connection in the form of a huge concrete box, meter vault, valving, piping, and other apparatus. The challenges for this project included a limited space for construction and rock excavation in an environmentally sensitive area. The cold and wet winter weather also presented a tremendous challenge for the contractor. For the town of Payson, this was a great effort for the first Cragin project construction in the Tonto National Forest. And in 2013, construction of the finished water pipeline from the water treatment plant site at Mesa del Caballo, 2 miles in length along Houston Mesa Road and cross-country to Tyler Parkway, was completed. A unique trenching method was used as a large trencher was employed in order to minimize the need to process rock on the site. The trencher actually grinds rock into an appropriately sized pipeline backfill material. This pipeline will eventually connect to the pipeline at Zurich Drive by means of a 1.5-mile section on Beeline Highway from Tyler Parkway to Zurich Drive to be built in the spring and summer of 2015. Many questions existed about how all the elements of this new water source would be incorporated into our existing water system. That included our SCADA system. SCADA is an acronym for Supervisory Control and Data Acquisition. It's a process that controls our entire water system via a computer terminal. The process includes monitoring all the tanks and wells in town with the ability to remotely control flows and levels independently for each element. Our current SCADA system will be updated to include the ability to monitor everything from Payson's connection to the existing Cragin water facilities at Washington Park, conditions all along the new pipeline, and to monitor water treatment plant and power generation plant operations. We will also receive data from SRP to give us the ability to monitor their Cragin and pipeline operations. What still needs to be done? The raw water penstock, that is the 12.5-mile pipeline from the tail race connection at Washington Park to the future hydroelectric generator plant and water treatment plant facility at Mesa Del, is one of the items. The alignment for the pipeline project is adjacent to Forest Service roads with a 3/4-mile cross-country bypass of the narrow Houston Mesa Road on the north side of Whispering Pines, and then continuing adjacent to Houston Mesa Road all the way into the Mesa del Caballo treatment plant site. Some of the challenges for this portion of the project are rock excavation, tight working conditions along the roadway, over 70 culvert crossings, and 3 crossings of the East Verde River. Concurrent with penstock construction will be the construction of the water treatment plant and hydroelectric generator. There's water treatment plants everywhere, hydroelectric generators, pipelines, but they aren't all part of the same project. It's just very difficult to find anywhere. And the fact that it was able to be done in rural Arizona by a very small community is probably what makes it unique, because you're building facilities that are going to be able to serve water to the town of Payson theoretically for hundreds of years, but you're having to find a way to do it with today's dollars and today's resources, because you can't build half pipeline. You got to build the whole project out right now, even though you may not use that project in its entirety for 50 or 60 years. That is probably the most unique aspect of the project.